is actually on the written test?
Is what going to be on the written test?
The stuff.
All this stuff that I'm erasing?
Yeah.
Yes, as well as the stuff that we're going to learn today. How many questions are on the written exam? On the written, I think I had 16, so theoretically, it's not going to take longer than the other one, but you know what? Take as much time as you want.
And then what about the Excel portion?
The Excel portion, I haven't made it yet. I had more time on that one. So, well, the nice thing is I can give you lots of questions, so I'll probably test all your hypothesis tests. So that one might take a little longer. But I don't think the written will.
So when you say a little longer,
2 hours, maybe. Okay. So they wouldn't let me end it on Friday. I don't know why. They wouldn't let me start it on Wednesday. So I was. So here's the weird thing about the test. So the weird thing was I accidentally scheduled the computer test for next week, which was going to end on a Friday. But this week they wouldn't let me end it on Friday. It had to end on Thursday. So I'm like, okay, Tuesday through Thursday it is. So then the written test, I actually input it as a written test instead of a Scantron test. So it's going to be a Scantron test. So you will want to bring a number 2 pencil. It's going to be mostly multiple choice. There will be a few that you'll have to write on the test, which is fine. But I'm doing that because it's going to make grading really fast for me. Because I'm going to try to get them back to you Monday. So that's why I said if you can get it done before noon Thursday, I'll give it back to you Monday. If you don't, I'm not. I'll give back everybody who's got it done by then. But if you have to take it Thursday afternoon, take it Thursday afternoon. That's fine. But anyway, so I went to reschedule a different test that said Scantron plus Write-On, and it made me forced to next week. So I think the testing center is going to be full this week because you can't. I think it's closed Wednesday and I think it's closed Friday.
What?
Wait,
What? Closed Wednesday?
I don't know. No, it's not closed Wednesday, but for some reason it wouldn't let me schedule it on Wednesday. I don't know why.
There's
So
an
we
anatomy
can't.
test this week, and that's.
And that's in the
they
testing
usually
center?
are overflowed on Friday.
Yeah, so anyway, I think it's going to be full. So plan on that.
So the computer test runs when through when?
Both tests run Tuesday through Thursday.
So we
Both
can
Tuesday
do
through
Wednesday.
Thursday.
You can take it Tuesday, Wednesday, or Thursday.
Both run Tuesday through Thursday.
Okay? So anyway, sorry, I had to work with their scheduling. It wasn't the best. Okay, so got the wrong folder. Okay, we're going to talk about independent sample two sample t-tests. Okay? So this is kind of a follow-up. In some ways, it's similar to the dependent test that we just did. So this is 2 means independent samples. Okay? So, couple of the big differences I want to point out. I just want to remind you, this one and the one we did Thursday, this is the most easily confused. How do you pick independent? How do you pick paired? Okay? Most easily confused. So the main differences. Dependent must have equal ends. Okay? You've got to have a pair. If it's not a pair, what do you do with it? You throw it out. Okay? Independent can have different end. It can also have the same end, it doesn't matter, but it can have different ends. So you don't have to throw out any data, which is really nice. In fact, they could be really, really quite different. So as far as rules go, very similar rules with the dependent test. Number 1, simple random sample. Number 2, this time it's independent. Obviously, that's kind of like that. But number 3, very similar. They should be normally distributed. No outliers. Number 4, your N1 should be greater than or equal to 30, and your N2 should be greater than or equal to 30 as well. So once again, they don't have to be the same size as they do on the paired. I mean, in real life, you'd like them to be, but it is not required. Okay? Okay, so here's what I'd like to do. Go ahead and open up your Canvas, open up that same spreadsheet we were working on a few days ago. If you go to, sorry, I guess I should show this. Go to your in-class worksheets on the bottom. It's 11.1 and 11.2. Okay, so I've just got the data here. Forgot to tell you what's going on with this data, so I'll just type that in really quick. If you're interested, on Space Lab, 14 male rats were sent into space. Upon return, the red blood cell counts of the rats was determined. Control group of 14 rats stayed on Earth. Use alpha equal 0.05. Want to see if difference between Earth and space rats. Okay, first question is what? Quantitative, qualitative regression. Quant, qual, or regression.
Is it not categorical? Is it qualitative?
So qualitative, categorical, same thing. So, quantitative, lots of numbers. Not only is it quantitative, it is not discrete either. These are definitely continuous numbers, right? Okay. All right, question number 2. Okay, so this is going to be a difference on your null hypothesis and your alternative hypothesis. Okay? Let's talk about the null hypothesis again. What does null hypothesis mean? Yeah, there's no changes, so no change, no difference. Right? Okay, so how do I convert that to a mathematical statement? Something's got to equal something. What'd you say?
0.
Now, do we think the red blood cell count is 0? No. Okay, so here's the big difference. In this case, with independent, we're going to say that mu1 equals mu2. With dependent, what do we say with our null? We say that d equals 0. Okay? So that's for dependent. This is for independent. In independent, we just set them equal to each other. Okay? Does that make sense? So that's kind of a notation thing. I mean, you could argue that mu1 equals mu2 here, but we don't do that because we subtract the means. Or we subtract the data, not the means. Subtract the data. So this is the convention that we use for dependent. This is the convention we use for independent. Okay? So just make sure you remember that. Okay, so in this case, we've got mu1 equals mu2. Or if you wanted to be really specific, you could say mu space equals mu Earth. That's probably a little bit more descriptive. Okay, your alternative hypothesis. Anybody know what space does to your red blood cell count or to rats' red blood cell counts? You know that?
No, so it's just not equal.
Maybe you're sick. I don't know.
I've never been to
I'm not a biologist. I don't know anything. So, and it doesn't give me any indication in the problem. So mu1 is not equal mu2. Okay. Done. Okay, question 3 is your test statistic, right? Specifically, what I'm asking is a z, a t, an f, or a chi-square. And how do you know? Chi-square? Chi-square is usually categorical or standard deviation, right?
It's probably an F test since we haven't done
There's an F test.
T, isn't it?
Why do you say T?
Because I have it written down as T equals 2 sample means.
Okay, it is a t-test. Okay, we've got various iterations of the t-test, right? Why, now, just, let's answer this question first. Why is it a t-test and not something else? Because what? We're dealing with means, but it could be a z-test, right? We do z-test with means, right? So why is it a t-test, not a z-test?
It means.
Because we don't have any clue what the population standard deviation of red blood cell counts for rats, or maybe some of you know. Anyone know? Okay, no idea. So it's got to be a t-test. Okay. Now it's not due to any t-test. This is a 2-sample independent means. Now why? Now let me ask you a question. Why is it independent? And could I simply pair rat number 1 and rat number 1 and rat number 2 and rat number 2? Could I pair them up? Now, I could make this a dependent test. That's a good point there, Cooper. I could make this a dependent test. How? I could check the red blood cell before, and then send them up in space and check it after. Okay? So I could make this a dependent test. It would be the same rat, but these are 2 different sets of rats, right? So there's no reason to pair them up. Okay? So this is an independent sample test. Okay? Do you see why this is most easily confused with what we did on Thursday?
Yes.
Okay? All right. So 2-sample independent means, which means I've got to give you a new equation here. Okay? So the new equation is x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n2. Now, as you probably noticed by now, I probably left something out because, why? Because it's 0. What did I leave out? Minus mu1 minus mu2. Okay? That's going to be on your formula sheet. It's going to be 0 because of what? Because we say that they're equal. Okay? With our null hypothesis. Okay? All right, so just remember that. That's always going to be 0. So now, oh, by the way, okay, let me point this out also. Degrees of freedom. Okay? There is a complicated formula in the book that you can use. And if you want to be super accurate, you can use it. Here's what I'm going to tell you to use. Okay? Your degrees of freedom is going to be the smaller of n1 and n2, whichever one is smaller, minus 1. Okay? That's going to be good enough. Now with the formula, you could get like a 16.3 degrees of freedom or something like that. Okay? Obviously, that's going to be very hard to look on your chart, right? So this is going to be the easier way to do this. This is the way I will have you do it. But technically, if you want to be more accurate, this is the better way to do it. Okay? And it is the way that most software does it. But that's a whole lot easier to remember, right? Okay? All right. Okay, so let's figure out our, so according to my formula, what do I need to know? I need to find my means, and I need to find my standard deviations, okay? So my means are simply average of my space rats, average of my earth rats. My standard deviation is the standard deviation of space Okay, so as we look at these really quickly, what do you notice about your means?
Pretty close.
Looks like space is a little bit smaller. The question is it significant? Your standard deviations, okay, standard deviations look pretty similar though, right? Okay, all right. So we're going to do our t-score. T equals x1 bar minus x2 bar. Now, by the way, does it really matter which way I label this? It doesn't. In my case, I got a negative number. But if I did Earth minus space, I would get a positive number, right? Okay, that's okay. And in fact, in this case, it doesn't matter too much because it's a two-sided test, right? So just remember, whether it's x1 minus x2 or x2 minus x1, it doesn't really matter as long as you know what you're doing. Okay? All right, so I got a negative number. So when we talk about this, am I going to be doing, now I know it's a two-sided test, but if I got a negative number, is it going to be a left tail or a right tail? It's going to be a left tail. Okay, so I'm going to be over here somewhere. What's the mean? Huh? Should be 0, right? If you subtract the means, the difference should be 0. Okay? All right, so let's figure out my denominator. My denominator is going to be the square root of S1 squared divided by N1, which I forgot to figure out, 14, right? Plus S2 squared divided by 14 as well. Okay, let's talk about our n's. So N1 equals 14, so is N2. And my degrees of freedom equals 13. Okay? All right, so now I'm going to take this number here and divide them. I'm going to get this divided by that. Okay? So that's my t-score, right? Okay, so I get a t-score of negative 1.43. 1.43. Okay, I want this area here because it's on the left side. Okay? Now, next step is I'm going to find my p-value. Now, here's a little tricky thing here. Okay, so I can do a t dot dis dot two-tailed, right? Okay, so I put in my t-score. I put in my degrees of freedom, and why didn't it work? Okay, the two-tailed test is expecting a positive number. If you want to do a negative number, now it will work. Okay, now, so that's one way to do it. Or you could say, okay, well, I'm just going to do a t dot dist. That's going to be a left-tailed test. Left-tailed tests are fine with negative numbers. My degrees of freedom is still 13. What do I put here? True. Okay. Okay, now I need to double that. I got the same number that way. Okay? So that works as well.
Can you double that to both sides?
Double it because it's a two-tailed test, which I didn't write on the board. But yes, your alternative hypothesis, mu does not equal, mu1 does not equal mu2. So it's two-sided test. Okay? So either way is acceptable. Okay? Okay, finally, what's my conclusion? Oh, before I do my conclusion, reject or do not reject?
Do not reject.
Do not reject. So my conclusion is
There is
there is not enough evidence that what?
the difference
Instructions.
between Earth and space
Rats
rats.
are different than Earth rats. Okay? Alrighty, so So I'll post this up on the website. So reminder, tomorrow quiz is 11.3. We'll do a review tomorrow. After that, we'll just keep moving on. Okay?
So you'll post it.
I'll post this.